Your AI is running 40,000 simulations. But if you're only checking the final output, are you missing the single failure that breaks everything? When we build advanced agentic systems, the problem isn't generating an answer. The problem is guaranteeing that the process leading to that answer was robust, predictable, and safe. Most verification harnesses perform a shallow check. Did the agent produce an output? Was it within acceptable bounds? This is insufficient for large-scale, complex decisioning. We need to move beyond simple output review. We need a safety net, a verification middleware that monitors the entire execution journey, not just the destination. This middleware operates as a parallel execution auditor. It runs alongside your primary agent, observing its behavior in real time against predefined system invariants. Its job is not to predict the answer, but to detect anomalous behavior the subtle drift into an unsafe or computationally unstable state. Think of it as a temporal gyroscope. It tracks the sequence and timing of micro-decisions, ensuring that the agent didn't linger in a computationally expensive loop or miss a critical dependency. One critical layer is the constraint solver. While the agent pursues its goal, this solver continuously checks if any intermediate action violates a hard boundary condition. If the agent enters a state where the goal is logically unreachable given current constraints, the middleware flags this failure immediately, long before it consumes valuable compute cycles. This is the difference between a costly runtime bug and an early-stage, preventable architectural flaw. So, how do you architect this? You need 3 distinct verification layers integrated into your workflow. Layer 1, Semantic Consistency Check. Does the agent's current belief state align logically with its initial goal and observed environment? It doesn't just check syntax, it checks *meaning star. If the agent believes task complete but the environmental inputs suggest ongoing conflict, that's a failure. Layer 2, Behavioral Fingerprinting. We train a model on successful runs to establish a healthy execution profile, a sequence of actions and decision timing. When the agent runs live, any significant deviation from this learned profile triggers a high alert flag. This catches emergent behaviors that are technically valid but practically unstable. This is crucial for catching cascading failures, where a small initial error compounds into catastrophic system behavior much later. Layer 3, Adversarial Probing. The most advanced layer involves a dedicated, minimal agent whose sole purpose is to actively try and break the primary agent's assumptions. This isn't just testing, it's simulated failure injection. The prober throws edge cases, zero-shot inputs, noise spikes, resource constraints into the primary agent's operational environment. If the primary agent maintains coherence and successfully navigates these injected failure modes, you have verified its true operational resilience. Scaling this infrastructure means thinking of your verification harness not as a quality gate, but as an extension of the agent itself, a metacognitive layer. It allows the AI to not only complete tasks but also self-diagnose the integrity of its own process chain. Moving from prototype to production scale requires moving from isolated tests to continuous, high-throughput adversarial simulation. The goal is to reduce the costly human intervention time from a post-mortem analysis down to preemptive parameter tuning. This isn't just about reliability. It's about the operational economics of advanced AI. If your agents are complex enough to potentially fail in novel ways, they need a verification stack equally capable of finding those failures. So, audit your outputs. But more importantly, audit the entire journey. Because the single failure lurking in the noise is always the one you need to find.